So one of the technologies that plays a pivotal role in blockchain and making blockchain secure and immutable is cryptography. If you've never heard of cryptography before, cryptography is simply defined as the science of sending messages back and forth from one party to another in the presence of adversaries or bad actors, participants who may wish to corrupt or change the contents of a message. And there are some key concepts you should understand about cryptography before we really dive in and talk about how cryptography protects the data on the blockchain. Most cryptographic functions are what we refer to as two-way functions, meaning that we can take a secret and we can encrypt it, and then we can use that same process to decrypt the secret at the other end. So some of the key objects or concepts to be aware of in cryptography, first of all, are the secret. What data are we trying to protect? What is the message we're sending back and forth that we want to do so in a safe, secure fashion and try and guarantee that it hasn't been tampered with? We take our secret and we combine it with a key, a piece of data that is consumed by a function, our third component. When the function receives the key and the secret, the function uses the key to change the data in the secret to create the fourth and final component, which is known as the cipher. And the cipher is simply the encrypted message, the thing that if it were intercepted, if it were seen by anybody else, any non-participants or bad actors, they wouldn't know what the secret was, they wouldn't know what the message was, and they wouldn't know how to decrypt that cipher back into the secret. Now again, most cryptographic functions are two-way, meaning it doesn't do me a lot of good to encrypt data if the receiving party at the other end can't decrypt it. And oftentimes all this involves is using the same key or reverse key into the same function with the cipher as input to get the secret back out. So when we talk about cryptography, keep in mind those four basic components: the secret, the key, the function, and the cipher. Then understand that cryptographic hashing is a very special class of cryptographic functions, which, unlike all their cousins, are only one way. Meaning that in a cryptographic hash, I can put information or a secret into it. The key and the function are contained as one entity, and what I get back out is encoded data. I get what's called a hash or a hash result that is an encryption based on the data that I put in that is mathematically impossible to reverse engineer, and this is what makes it a one-way function. If you put any data into a cryptographic hash and you share that hash with me, there's absolutely nothing I can do above and beyond random guessing to try and recreate that input to tell me what your original secret was. Cryptographic hashes are used in scenarios where we want to prove a piece of data without sharing that data. So password management systems use this all the time. We don't want to store a username and password, we want to store a username and the hash output of a password. That way I don't know what any of my users' passwords are, but I do know that if they put the wrong password in, they're going to get the wrong hash back out, and I can easily validate that a user's password is correct or incorrect without having to know what it is. And we're going to dive in a lot deeper in a later module to show you exactly through a demo how cryptographic hashing works and how it provides security and immutability on the blockchain. But just understand these two big takeaways. Number one, that cryptography is normally a two-way function with four components: the secret, the key, the function, and the cipher. And then finally, there are a subclass of cryptographic functions called cryptographic hash functions, which exist as one-way functions, which can only encrypt the secret, and again, which are mathematically impossible to decrypt the secret in any other method other than randomly guessing input until you're able to recreate that hash output. And these are key components which enable security and immutability on the blockchain.